Standing proud off the coast of Dubai is one of the most incredible buildings on the planet. At 321 meters, it soars higher than the Eiffel Tower. It's the tallest hotel on Earth and the most luxurious. Its name means the Arabian Tower. This is the Burj Al Arab, a structure designed to amaze. But creating this 21st century icon was an epic struggle that pushed everyone involved to the limit. In November 1994, construction began on the world's tallest and most luxurious hotel. The pressure was on from day one. With the eyes of the world watching, no one on the project wants to disappoint this particular client. Sheikh Mohammed bin Rashid Al Maktoum, then Dubai's crown prince, is the visionary behind this amazing building. The project is his response to the economic time bomb his country confronts. As his close advisor, Sultan bin Sulayman knows all too well.
He knew that we don't have oil. He knows that oil is going to end someday. And they have two choices. Either go and do something about it and find other alternative ways to sustain the life for the people of Dubai, or sit waiting for help.
Only 50 years ago, Dubai was a dusty backwater, home to pearl divers, coastal traders and Bedouin. Then, in the 1960s, prospectors discovered oil. The sudden injection of billions of petrodollars transformed the sheikhdom. But geologists predict the oil boom will be over by 2016. A good life could end just as quickly as it began, when the wells run dry. The answer to Dubai's economic survival lay in its geography. This tiny emirate, less than twice the size of London, is in the remote Arabian Gulf. But Dubai had three untapped assets: sun, sand, and sea. Facing a future financial meltdown, Sheikh Mohammed made a crucial decision. He decided to turn Dubai into one of the world's most exclusive holiday destinations, a playground for the rich on the Arabian Gulf Coast. But the Sheikh needed a luxurious centerpiece to launch his country into high-end tourism. He staked what some estimate as £1 billion on the tallest, most lavish hotel in the world, with a unique 7-star reputation, the Burj Al Arab.
I think it was very important to put Dubai on the map of the world. There's no hotel like this hotel. It takes guts, and Sheikh Mohammed has a lot of guts.
The Sheikh's courage is clear from his choice of architects. A radical young team from Britain, brave enough to take up the challenge, but very short in experience. They were led by Chief Architect Tom Wright.
We had an average age of 32.
Not a grey hair between us.
And none of us had gone over about 15 stories.
I was quite staggered by the scale and the immensity of the project.
Tom Wright and his colleagues have a reputation for innovative engineering, but they're more used to designing schools and offices. But Dubai is a place where connections are crucial. Through a contact in the ruler's office, the team got its break. Sheikh Mohammed agreed to a meeting and was so impressed with their initial concepts, he awarded them the contract. Wright must turn his sketches into a design so remarkable the building becomes a world-renowned landmark.
We had many sleepless nights worrying that the building we designed wouldn't turn out to be at all iconic.
Wright knew he must push his design to the limits. A building only becomes an icon when its form is simple but unique.
We decided that if you could draw a building simply with a few strokes of a pen, and it was instantly recognizable as not only the building, but the place, Egypt in this case. You created something that was iconic. So if you consider these buildings in the world, there are probably no more than 10 maximum that have actually achieved this status. Australia, Sydney Opera House. As with all these buildings, it's usually just the first couple of lines that actually make you know exactly where the building is. Paris. And you have to put a flag on the top.
Building an icon is a once-in-a-lifetime challenge few have pulled off. The team had to compete with the likes of Gustav Eiffel. All the brainstorming paid off when Wright finally had his eureka moment.
We were sitting there having a beer, watching the modern sailing yacht come out of the Dubai Offshore Sailing Club. You think of excitement, you think of exhilaration, and we went, hey, this must be the one. The form we came up with is very simple, and within a few lines, I think you can see that it has all the elements of an iconic building. It's simple and instantly recognizable.
The concept immediately caught the Sheikh's imagination. A sail billowing in the wind has deep meaning for the people of Dubai, a seafaring nation. To complete the nautical image, Wright wanted the structure to rise out of the water like a massive yacht. But this would require an island as a base, and there are none in the area. Wright was undeterred. He proposed they build an island specifically for the hotel, a first for Dubai. Constructing the hotel out at sea would significantly add to the risk and cost. Wright would have to persuade his colleagues this radical scheme could work.
I remember I was pulling the sail out to sea, and the rest of the design team were pulling the sail back onto the shore, and this continued to go backwards and forwards before finally the client stepped in and said, no, it's going to be out at sea.
Sheikh Mohammed was prepared to take the risk. The hotel would be built 270 meters off the coast. No one had ever built a tower this high on an artificial island. This 321-meter structure, weighing 250,000 tons, will need to stand firm against earthquakes and Gulf storms. Wright has won the first of many battles. The Burj will rise out of the sea. But time and again, his refusal to compromise would force his colleagues to push the boundaries of engineering to the limit. By early 1995, the construction team was hard at work, building a low-lying island for the world's tallest hotel, the Burj Al Arab. But the young architects were about to get a taste of Dubai's extreme weather. April the 27th, a powerful storm known as a shamal swept across the Gulf, hitting the coast with a vengeance. A set of construction barges lay in its path, each laden with 10,000 tons of rock. The architects had planned for all weather conditions, but the storm's intensity still shocked Simon Crisp.
We had 3 or 4 metre waves bashing onto the beach. To see the waves coming in like this was really quite a wake-up call for us.
As one huge barge broke loose and slammed into the mainland, the team realized the damage this kind of storm could inflict on their island hotel.
We had a really graphic example of how powerful the Gulf of Arabia can be when it's angry.
The architects' decision to expose their structure to these forces could have serious consequences. The engineers would have to struggle to produce a low-lying island still capable of resisting nature's fury. Just 5 months into the build, the team have reached a critical phase in this one-of-a-kind construction project. A debate has been raging over the height of the island. Architect Tom Wright wants to make it low to give the impression of a sail rising out of the water.
We argued a lot about the height of the island. From a design point of view, I wanted people to be close to the sea.
From the start, he's gone head-to-head with engineer Mike McNicholas, who's responsible for the island's design.
So I mounted the island as low as you possibly could, you know, skimming the sea. I'm coming from the other end, needed to make sure we were protecting the island.
McNicholas's worst fear was that waves breaking over the island could damage the hotel or even drag guests into the sea. Initially, the engineers planned to build the island from rocks. They're available locally and the technology works. But Wright rejected this plan. A rock island would have to be far too high and wide to repel the sea safely. To keep the island low, McNicholas experimented with pioneering concrete blocks designed to reduce the impact of the waves. But no one in the Gulf had ever used these blocks before.
I had to insist with the team that we carried out tank testing. It was the only way we were going to be sure that the island would be safe.
These tests replicate the power of the tallest waves that can occur once in 100 years, then send them crashing into a series of differently configured models. 3 weeks of testing proved the hollow blocks work. The construction team built the island with steep rock slopes, then covered them in the concrete blocks to absorb the force of the waves. These ingenious blocks work like a sponge. As the wave hits, the water passes inside the space and turns around on itself. The force is largely dissipated. With the engineers' help, architect Tom Wright has won his battle for a secure low island that rises only 7.5 meters above the waves. November 1995. The artificial island for the world's tallest all-suite hotel was now complete. The construction team could start phase 2 of this unique project, the foundations. The support needed for any skyscraper is vast. But the location of the Burj Al Arab presented an added challenge.
It had never been done before to build something like this on reclaimed land. I mean, we're talking about a 300-metre high tower on a man-made island in 6 meters of the Arabian Gulf.
The problems multiplied when the results of core tests revealed bad news. The drilling team searching for bedrock for the foundations drilled deep into the seabed. But even a full 180 meters down, there was no solid rock. This would make their job tougher, but the architects remained defiant.
The average person would think we're crazy to build something like this on sand, let alone out in the water.
This 321-meter structure has to stand firm against earthquakes and 90-mile-an-hour winds. But its foundations depend on nothing more substantial than sand. The architects had a plan. They'd support the Burj using steel-reinforced concrete foundation piles drilled deep into the sand. To stop the whole building from just sinking, they'd rely on an effect known as skin friction, the resistance that stops two rough surfaces slipping past each other.
Skin friction is all about the contact between the sand and the surface of the pile. And the longer the pile, the further in the ground it is, the greater that effect. And I'm going to demonstrate it now by whacking it in. You'll see it starts to move quite quickly with the first few impacts. Now it's starting to stiffen up a bit, even though I'm not hitting it any harder or any softer, and the skin effect is starting to really kick in here.
Once the friction between the post and the sand around it equals the load of the hammer, the post comes to a halt. But Crisp's scheme would only anchor the Burj if the sand is compacted enough to create resistance around the building's piles. The drillers pack sand samples into sealed containers and send them off to be analyzed. If the results show the sand is too loose, then support on the piles anchoring the building could suddenly fail. In the southern end of the Arabian Gulf, this threat could be particularly serious. Dubai lies within range of a major fault line, so this soaring megastructure might be vulnerable to earthquakes. In June 1964, a 7.5 magnitude earthquake hit Niigata in northern Japan, an area also built on sandy silt. The tremors flipped over entire apartment buildings as the ground gave way beneath them. This wasn't normal earthquake collapse. The devastation was due to a phenomenon known as liquefaction. As grains of loose sand shake, they fill up any air pockets and compact, taking up less space. The ground stops behaving like solid earth and settles like a liquid. On shifting sand, any building could simply topple. When the results of the drilling tests returned, it was good news. Deep beneath the site, they found compacted and calcified sand. Liquefaction is not a threat. But the foundations must be long enough for the skin friction to hold them firm.
We weren't going to take any chances, and we extended the piles by another 8 meters.
CRISP specified foundations over 20% longer than originally planned. These 250 concrete piles have a combined length of over 6.5 miles, 35 times as long as the towering hotel they will support. One by one, the engineers were solving the challenges thrown up by this extraordinary structure. But in 1996, they braced themselves for a new set of obstacles as they began Phase 3, the construction of the hotel itself.
This building had to stand up to the worst that the Gulf could throw at it.
The hotel has slender concrete walls, not capable of withstanding the elements alone. To hold them firm against high winds and earthquakes, the architect devised a visually stunning solution. A gigantic steel structure outside the main building known as an exoskeleton. A series of vast diagonal trusses tie 2 huge steel bows to the concrete core at the back of the building. Wright's design makes the building unique. But his giant diagonal trusses would make life hell for Anthony McCarter, the engineer who had to make them work.
Those trusses gave me 4 months of heartache, sleepless nights, worries, anxiety.
They must be incredibly strong to tie the exoskeleton together, but aesthetics are just as vital.
It was critical that these diagonals were very, very elegant and also very beautiful as they're so visible.
This building had to amaze the world and make Dubai a must-stop destination. Wright was not about to compromise.
I used to go to Tom with option after option. I remember one particular occasion where I had 7 options and he went, no, 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 no good, no good, no good.
Eventually, McCarter found a form that worked structurally and was graceful enough to fit Wright's vision. But this in turn caused nightmares for Malcolm Murphy, the chief contractor.
It's okay for the architect to draw pretty pictures, but we have to build it.
He found a factory just 10 miles from the construction site capable of welding the huge diagonals. Each one is longer than the Airbus A380 Super Jumbo and heavier than 20 double-decker buses. Welding complex forms like this in the factory isn't simple, but it's nothing compared with transporting them to the site. With each truss weighing in at 165 tons and reaching a staggering 85 meters in length, it was no easy task.
And the challenges to do that are just unbelievable.
No one has ever transported anything this size before in Dubai, but Murphy was not going to be beaten. He brings in one of the world's largest heavy-lift transporters, a beast with a total of 80 wheels. It makes the slow journey to the construction site at an average speed of 4 miles an hour. Police must close roads and remove traffic lights to allow this convoy through. When they finally reach the site, the contractors face their next hurdle, lifting these 165-ton beasts into position.
The architects refused us point blank to position these things in 3 pieces, which we wanted to do originally. And he said, no, aesthetics, I'll not learn you to weld up there.
He's forced to find a way of lifting the trusses in a single piece to a height of 200 meters, twice the height of the Statue of Liberty.
We had to go away and think of an idea how to actually lift these monsters up. We had 3 big monster cranes in there, and even they weren't big enough to lift the diagonal trusses.
Murphy had to look further afield for a solution. Specialist lifting gear from Singapore. His team set up winches, like those used on offshore drilling rigs, high on cantilever frames 15 meters from the building. Cables with a braking strength of 225 tons are attached to the ends of the truss.
I can assure you we were very, very nervous that morning when we lifted the first one. 30 or 40 guys had sleepless nights that week, getting ready for that first lift.
The 2 massive winches take up the strain, then painstakingly raise the diagonal truss little by little up the side of the building. It's all going to plan. Murphy and his team have solved the lifting dilemma, but these trusses have a sting in the tail. They need to fit into place with pinpoint accuracy. But Dubai's climate means temperatures can vary by as much as 14 degrees in a single day, and this will make the trusses expand and contract dramatically. The problem's known as thermal expansion.
The steelman's nightmare in the desert, working 50 degrees C.
Steel expands in the heat and contracts when cold.
Okay, chaps, light up. We're actually going to heat the steel up now, which is going to give you an idea of what temperatures we're working in the desert.
Heat makes the steel molecules move faster and further, and this 15-meter tube actually grows in length. The difference is visible.
What did I tell you? Steel does expand with the heat.
The diagonal trusses on the Burj Al Arab could expand and contract by a full 5 centimeters over a 24-hour period. They were never going to fit their precise point in the framework without an ingenious solution.
Engineers thought about it, the structural fabricators, the steel fabricators, the architects, everybody thought about it, and it was actually one of the architects came up with this great solution.
On the frame of the structure, the fixing bracket contains a vast washer with its hole offset from the center. This swivels until it lines up with the hole in the diagonal truss. Then, the cast steel pin, 30 centimeters in diameter, is inserted through both holes, locking them together. This clever device buys the team the crucial 5 centimeters of play they require for the installation, and the truss is now fixed securely in place.
When we got that pin in, we had those champagne corks flying. It was just unbelievable.
But there's precious little time for celebration. The first guests are due before the millennium. This leaves the team less than 36 months to completion. It's a race against time.
Sheikh Mohammed's vision for the Burj Al Arab meant that it was needed yesterday.
January 1997, and a colossus is emerging out of the Arabian Gulf. The Burj Al Arab will become the tallest hotel in the world, the last word in luxury and a proud symbol for Dubai. Architect Tom Wright wants the building to be beautiful. The steel sections of the exoskeleton that will support it must be as minimal as possible. The view from these £1,000 a night suites would have to live up to the price tag.
When you're in the suite, looking through the windows, they are right in front of you, so they have to be exceptionally well detailed and well put together.
But this created a dilemma. If Wright make the exoskeleton too light, the wind's force at 300 meters above the Gulf could shake the building apart. Too bulky, and the elegant form of his yacht-shaped structure would be ruined. Once again, Wright and the engineers, who must make his hotel safe, were on a collision course.
When you're designing a building that is taller than the Eiffel Tower, and you've never done one before, you want to make sure that you've got it right.
The form with its steel exoskeleton was so groundbreaking. For the first time in Dubai's history, engineers decided to do tests in a wind tunnel. Wind engineer Volker Buttgereit knows the Burj Al Arab is one of a kind.
Before this building came along, most of the buildings in the Gulf were fairly orthodox shape. They were square, they were rectangular, they were nowhere near this scale. So doing a wind tunnel test for a building in those days in the Gulf was almost outrageous.
But for this extraordinary structure, it was essential. The wind tunnel simulated the wind effects of the Gulf around this 1:50 scale model.
This building has seen some pretty severe loads, almost twice what it would be seen in London. We measured suctions which were the order of a weight of a car hanging off, trying to suck the panel off the building. So that's quite something.
The wind tunnel threw up results that could threaten the entire exoskeleton.
When we first saw the design, there was immediate concern about vibration due to something called vortex shedding.
Vortex shedding is an engineer's nightmare. Certain wind conditions blowing over sharp edges on the steel structure can create miniature tornadoes. These set up dangerous vibrations that can shake a building to destruction. Which is exactly what happened to these massive cooling towers in Ferrybridge, Northern England, in 1965. The engineers needed to find a way to protect the Burj Al Arab.
The simplest solution is to change the aerodynamic shape, but that upsets the architect.
The architectural idea of the exoskeleton structure is, when you look at it, the very essence of the building. If you take it off, it's just another building. If you put the exoskeleton structure on, you have an icon.
The architect forced the engineers to think again.
This is classic vortex shedding. We realized we had to come up with something clever that was not visible, but somehow reduced the motion.
They turned to an ingenious hanging weight called a tuned mass damper. These are installed at vulnerable points in the exoskeleton. When the wind blows and vortex shedding starts to create dangerous vibrations, the 5-ton weight will swing instead of the structure and damp down the vibrations to well within safety limits. 11 of these systems are fitted from the top of the 60-meter mast all the way down through each of the steel bow structures. These dampers safely cancel out the threat. June 1997, and Dubai's reinventing itself as the luxury tourist destination. This old hotel has to bite the dust as the Burj Al Arab, the symbol of the new Dubai, approaches its final form. Just 30 months before the deadline, the crew begins constructing the toughest engineering challenge. Sheikh Mohammed wants the building to impress, so the design calls for a restaurant that looks as if it's suspended in the sky.
I like the idea of the visitor sitting out in space, looking across the view towards the Arabian Gulf and Dubai, and sort of almost floating up in the clouds. The whole idea of hanging out over space.
This room is actually the size of most buildings, and Tom decided that he wanted to take it and stick it outside of the centre of gravity of the supporting structure. So there it was, dangling in the breeze with only the structural engineers to hold it up.
And if the engineers were to get the calculations wrong, the whole thing could tumble 200 meters to Earth.
Would give you a dining experience pretty unparalleled.
The Al Muntaha, or Ultimate Sky View restaurant, will soar 200 meters above the sea and project nearly 27 meters out on both sides from the building's narrow central core. Once again, right through down a gauntlet to structural engineer Anthony McCarter. It was his job to secure this eccentric wing-like structure with no visible means of support.
When Tom first showed it to me, I must admit I thought he was crazy.
McCarter found a solution to the pull of gravity that pushes conventional engineering to new heights. In the concrete core at the back of the building, he cast a series of steel brackets known as embedments. 10 enormous steel girders radiate off them, up to 1.6 meters high. These beams form the base of the rigid steel floor. The wing-like exterior was attached to it, and the entire restaurant could then be enclosed in aluminium and glass. This gravity-defying structure will survive winds of close to 100 miles an hour. It's an engineering triumph. But they were just 4 years into the 6-year program. No one could afford to take their foot off the accelerator.
The program was relentless and challenging. 24-hour working, 6 o'clock, site meetings in the morning, every morning.
You live, sleep, breathe the building.
The challenge really was on, can we design it and finish it by the original program?
The Burj Al Arab was due to open in time to celebrate the millennium, just 2 years away. The world's media was watching to see if the hotel would be the masterpiece the Sheikh promises, and if the team could complete it on schedule. The only way to deliver on time was to start the interior decoration long before the exterior was finished. In a temperate climate, this wouldn't be an issue, but humidity in Dubai reaches 100%, and temperatures can soar to a scorching 49 degrees. These conditions simply don't allow the team to fit delicate finishes like gold leaf, silk, and carved wood.
If we'd started to put materials that were susceptible to moisture at that time, they would have just fallen apart.
To make the deadline, the contractors needed to air condition this giant building site and bring the temperature down dramatically. The first step was to enclose the building by installing the final wall. Wright's iconic white sail, going to be...
When we first proposed the idea of the fabric sail wall, there was a lot of skepticism. People thought that it couldn't be done.
They stretched woven glass fibre sections between huge horizontal beams. The surface is pre-coated with Teflon to resist dirt and sand. The result notches up another first for the Burj, the largest fabric wall anywhere in the world. The reflective properties of the white sail will help keep the temperature down, but the contractors still needed to find a way for trucks to enter the building without allowing in the desert heat. The solution was to install a huge airlock. Trucks drive in, the vehicle pauses as the doors close behind it, a second set of doors then open, and the vehicle moves out of the building. The airlock and the sail wall seal off the building. But cooling a space this large during construction could create another setback. This unique structure now boasts the world's largest atrium, soaring to an amazing 180 meters. All this warm air can hold far more water vapor than cold air. If they were to cool this hot, humid environment too quickly, they could create uncontrollable condensation.
We could have had a rain cloud form at the top of the atrium and create massive damage to the interior design.
The only way to avoid rain clouds would cost valuable time. The contractors switched on the giant cooling system and brought the interior temperature down steadily by less than 1 degree a day. Given the schedule, it was painfully slow.
We started to cool the building down in June 1998. By December 98, it was pretty well down to temperature.
At last, the interior decoration could begin. But for a job like this, that has to be approved by the Sheikh, they needed a world-class designer. Quan Chu, who's already worked for the Sultan of Brunei, knows exactly what it takes to satisfy royalty. So, she was ideally qualified to take on the most luxurious hotel on the planet, with its daunting 202 palatial suites and 180-meter atrium. But she had just 24 months from design to completion to be ready for the guests booked in for the millennium.
I had a very, very tight program. So what we did was that the entire office, all 50 designers, just dropped everything else. Solidly, we just worked on the Burj Al Arab.
She not only faced a frantic schedule, Sheikh Mohammed was expecting her to amaze the world.
The brief basically asked us to design something that's never been ever designed before, and that will never be designed ever again.
Quan Chu and her team pulled out all the stops and began to produce interiors they hoped would match the Sheikh's ambition. But as they struggled to meet the deadline, another more severe problem came up. The Sheikh had a new requirement. He wanted to offer guests every conceivable electronic gadget in their suite. But this could have dangerous consequences. A new member of the team was suddenly in the hot seat. Electrical engineer Rob Roos faced the biggest challenge of his career.
There was a total redesign or a total change in the interior design, and that imposed overnight almost a 50% increase in the electrical load of the building.
The Sheikh's plans mean each suite requires an enormous 14 kilowatts. That's 8 times the load of a normal British house for every suite. With 202 suites, that's enough electricity for a town of over 6,000 people. In fact, it will power all the electric curtains, 52,000 lights, most of them on dimmers, and over 3,000 miles of electric cable. All these electronics can scramble the waveform of the electric current and create a problem known as harmonic distortion. This can melt the sheathing around live cables and start a raging fire.
That was a situation which was just totally unacceptable. We had to deal with that.
The people of Las Vegas know just how lethal an electrical fire in a hotel can be. In November 1980, in the city's MGM Grand Hotel, a pair of wires short-circuited. This caused a blaze that wreaked destruction. 85 people perished in this real-life towering inferno, and over 700 were injured. This was one of the worst hotel fires in history, all caused by a simple electrical fault. Roos needed a solution to the fire risk, and fast.
Obviously, the hotel was under construction. There were some fairly heavy deadlines to try and get the hotel finished and opened, and this was a major change.
His response took electrical engineering to a new level. He devised a harmonic filter system. First, it detects the electronic distortion. Then it sends a current that's the mirror image to cancel it. It's called antiphase and works like noise-cancelling headphones. His filters are now installed on every third floor, and at the point the electricity enters the building. No one had ever attempted a system on this scale before.
This was the largest active filter installation of its kind in a building like this anywhere in the world.
A world-class solution for a world-class megastructure. The team constructing the Burj Al Arab can claim a string of groundbreaking achievements. They built the first artificial island off the coast of Dubai, constructed the tallest atrium in the world enclosed by the largest fabric wall ever built, and with the mast finally in place, this structure is now taller than any other hotel on the planet. 5 years into the project, the team reached an important milestone. The iconic exterior was almost complete, but the interior decoration of the world's most luxurious hotel was seriously behind schedule. This stage had always been a race against time, but Sheikh Mohammed was about to send the design team into a tailspin. Dubai. By April 1999, the world's tallest and most opulent hotel was approaching completion. Everyone was rushing to finish the hotel, ready for the Millennium deadline. Interior designer Quan Chu was still operating in overdrive.
Christmas was cancelled, Easter was cancelled, bank holidays were cancelled. We basically made 50, 60-hour weeks.
Her brief from the Sheikh is to shock, to innovate, to amaze the guests with a modern Arab palace. And she delivers in spades, with 24,000 square meters of marble from Italy and Brazil, the equivalent of 3 football pitches. 8,000 square meters of 22-carat gold leaf give the desired impression of luxury. And she finishes the look with crystal chandeliers, woven silver and velvet. But for the world's largest atrium, Quan Chu made a radical decision. She went minimalist. She let the complex architecture speak for itself by painting it all white. The interior decoration was almost back on schedule, and Quan Chu was feeling optimistic. Then came the moment of truth. Sheikh Mohammed arrived to examine her work and pass judgment. The man behind the whole project was delighted with the ornate styling of the luxury suites. But that's where the good news ends.
I was summoned and said, when are you finishing off this atrium? I said, well, it's nearly done. Unfortunately, the feedback was no, where's the color?
The Sheikh rejected the white styling of the atrium. It was just too plain.
Not exciting enough, not bright enough, not colorful enough, not rich enough.
Quan Chu had to completely redesign and decorate the tallest atrium in the world in just 6 months.
I was basically living and sleeping in the Burj Al Arab, rushing from area to area.
With one last chance to get it right, she set out to dazzle. She designs a light show to animate the world's tallest fabric wall. Fountains create aquagymnastics in the lobby. Vast fish tanks welcome visitors as they ride the escalators. And crucially, she transforms the view up the atrium into a rainbow palette of vibrant colors. Everyone was on tenterhooks, hoping it would satisfy Sheikh Mohammed.
The adrenaline was pumping, sleepless nights basically before opening.
The Sheikh's response was a definitive yes. He was delighted and signed off on the project.
Sheikh Mohammed believes it became almost a 6 to 7 star hotel. And the achievement of his dream, the realization of his dream.
The doors opened to the first ultra-rich guests in December 1999, a full month before the millennium, and Sheikh Mohammed came to watch the final sunset of the century from his magnificent new hotel. Architect Tom Wright and the team have fulfilled the brief. Every part of this iconic structure is extraordinary. A spectacular combination of fire and water greets you before you even enter the building. In the ground floor restaurant, a team of divers care for 700 exotic fish in this 280 cubic meter tank. The result allows guests to get intimate with sharks while they eat. At the opposite end of the world's tallest hotel, this amazing feat of engineering, the Cantilever restaurant, delivers Tom Wright's vision of dining in the sky. Staying here doesn't come cheap. Suites cost up to £14,500 a night. And for guests with that kind of money, there's the helipad weighing 330 tons, projecting off the building a full 200 meters above the sea. When it's not being used as a tennis court by Roger Federer and Andre Agassi, it offers a very exclusive way of arriving at the world's most exclusive hotel.
The Burj Al Arab is a project of a lifetime. No other project will ever match this one.
The engineering triumph of creating Dubai's first artificial island has had far-reaching effects. It's paved the way for a series of enormous schemes, each more ambitious than the last. From the Palm Island, which sold out in 3 days, to the World Islands and beyond. The tallest hotel on Earth has laid the foundations for a secure future when the oil runs out. And it's all down to Sheikh Mohammed's foresight and architect Tom Wright's unique vision.
We knew from the start that we had the opportunity to produce something quite startling. And this project, I really think we achieved that.
An incredible new series next year on 5, exploring the concept of genius, asking if it's genetic or acquired or even an accident. My Brilliant Brain begins with a 7-year-old concert pianist. While on 5 US, it's dirty, very, very dirty. More in a moment.
Technology was used in the ancient world in some unlikely locations. There can be no more unusual place than in a temple. In ancient texts, we have uncovered stunning machines used in temples to create illusion and magic. Statues that cry tears of blood, temples that roar with thunder, and chariots that levitate in the air. All of these temple machines would use sophisticated engineering techniques. These were machines of the gods. Today, we are accustomed to the magnificence of the temples of the ancients and the gods that inhabited them. But it is only recently that the engineering marvels of the temple and its religious ceremonies are becoming known. What the ancient manuscripts now reveal might cause us to rethink everything we thought we knew about the ancient world.
We know from a whole host of references the diversity and the range.
Until quite recently, bonobos were thought to be just smaller versions of chimpanzees. They do resemble chimps, but they're a completely different species. Where chimpanzees fight and murder, bonobos are peacemakers. And unlike chimps, it's not the bonobo males, but the females who have the power. Much of bonobo life revolves around one activity: sex. It may even be the reason why they're so peaceful. These animals could give us new insight into our own background. In particular, where we get our gentler side.
Area for trade and for self-consumption is the fact that they have no alternatives. So by reactivating agriculture, we hope, 1, to increase supply of subsistence crops, 2, increase livelihood of families so that they don't have to get into the forest again to pay some basic needs.
Research at Wamba Forest has started up again, and Frances White continues to work towards re-establishing the site at Lumako.
My house was over there.
Her goal is to find the specific animals that she identified and tracked before the war.
Yes?
Oh, yes. But in the Congo, simmering tensions could threaten to boil over. Without long-term security, the jungles will remain a place to hunt animals rather than study them. But if research can be re-established and the bonobo protected, who knows what revelations they'll offer. The bonobo's world is a kind of time machine, an important rear window on our own history. Bonobos can provide us with insight not only into the evolution of intelligence, but into our own social nature as well. Now that they've managed to survive the war, we have the chance to discover more about our peace-loving cousins and possibly find out more about ourselves.
On Nova's last Great Ape website, meet an expressive bonobo named Kanzi. See a slideshow of bonobo gestures, explore a primate family tree, and more. Find it on pbs.org. Educators and other educational institutions can order this or other NOVA programs for $19.95 plus shipping and handling. Call WGBH Boston Video at 1-800-255-9424.